Good morning or good afternoon. I'd like to welcome everyone to today's Cisco Support Community Expert Series webcast. We're glad to have you with us. A few housekeeping notes to begin. As you entered the WebEx console, you either joined us by audio broadcast or by phone, which was automatically muted. Because of our large audience in attendance today, you will remain muted throughout the event. When you have a question, please feel free to enter it into the WebEx Q&A panel as you think of them. You can find the Q&A panel in the bottom right-hand corner of your WebEx screen. Please use the WebEx chat window for communication to the WebEx facilitator for any problems or issues you may be experiencing today. We would appreciate your input regarding today's webcast. A short survey will appear when you close your browser at the end of the event. So at this time, I'd like to pass it over to our host for today, Dan Gerson. Dan?
Thank you. Hello, everyone, and welcome to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast. Our topic today, troubleshooting adaptive security appliances, private internet exchange, and firewall service modules. My name is Dan Gerson, and I will be moderating today's event. Our expert joining me today is Kareli Sankar. Kareli is an engineer supporting Cisco's firewall team in Research Triangle Park, North Carolina. Her team supports the Cisco ASA, FWSM, and Cisco Security Manager, the Content Security and Control Module, and the Zone-Based Firewall Module in Cisco iOS software. Prior to joining Cisco, Kareli worked for the John Morrell Company, where she was the network administrator in charge of the company's enterprise network covering 27 locations in the U.S. She also was an adjunct professor at the University of Cincinnati, teaching undergraduate level networking courses. Kareli holds a degree in electrical and electronic engineering from Regional Engineering College in India and holds a CCSP and CCIE certifications. Welcome, Kareli.
Thank you, Dan.
Our expert panelists joining us today as well are CCIE's Elmedi Mabzin, Michael Robertson, and Enket Rodriguez. They will help in answering some of your technical questions during today's event. Now I'd like to briefly outline the format for today's event. Our expert will start with a presentation on troubleshooting firewalls for the first hour of the program, and then we'll provide an answer to the question, what do Cisco's security systems products and the location for the 2013 Super Bowl have in common? So stay tuned for that. Then we'll dive into the live question submission from the audience for the remainder of the event. During our live presentation, you may submit your technical questions to be answered by our presenter and the team of expert panelists using the Q&A box on the right side of the console. The team of experts is well-versed in firewalls, so please begin posting your questions now to give us the best chance of answering them. If you experience any technical issues, please post those questions into the chat. We'll also be asking polling questions during today's webcast, and we do encourage you to participate and answer them. You can also download a copy of today's presentation using the link in the chat window. Just as a reminder, everyone who joins today's webcast will receive 125 Cisco Preferred Access points. Now, let's get started with today's event. We'll kick things off with a polling question. What is the most common issue that you've encountered in your firewall in the last few months? Is it A, basic configuration issues? B, a latency issue? C, translation issues? D, failover problems? E, other. Take a moment to answer on the right side. Don't forget, you can submit your questions at any time, so please do so. Now I'm going to hand over the mic to our expert, Kareli, who will give you her take on the world of firewalls. Kareli?
Good morning, everyone. My name is Kareli Shankar, and I work with the firewall team here in RTP, North Carolina. Today, this will be the agenda that I'll be covering. Go over pre and post 8.3 plus NAT syntax, L2 adjacency issue, translation problems, firewall doesn't build any connection through the box, IPS global correlation issue, using the main interface to send data, how to use the packet tracer tool, how to map two different servers to the same IP address, and what is and isn't supported with the failover zero downtime, and some new features like scan safe and ASA content security module. Let's begin. What is NAT? Address translation substitutes the real address in a packet with a mapped address that is routable on the destination network. Many times, the private IP address space, the RFC 1980 address space that we use inside our network is not routable on the public internet. So we need to make ourselves look like a routable IP address when we browse the internet. The other reason is when we try to communicate with the remote network over the IPsec tunnel, the remote network may expect us to look like one of their own IP address schemes so they can route the traffic back to us. So these are the two conditions why we would do network address translation. Let's see the NAT 0 with the ACL or NAT exemption. The syntax isn't clear on the slide. Okay. So let's look at NAT 0 with ACL or NAT exemption. Let's see how to configure those. In the pre-8.3 syntax, what we would do is configure an access list. Let's say, for example, 192.168.2.0 network lives behind this firewall, and the 10.10.10.0 network lives outside of this firewall via the IPsec tunnel behind that router in the diagram. So my access list will include the source subnet, which is the network that lives behind my ASA, 192.168.2.0, destined to go to the 10.10.10.0 network. Once that access list is configured, I would configure a NAT inside 0. 0 indicates NAT exempted traffic, and tie this access list to that NAT line. The NAT 0 line tied to an access list is bidirectional. This means traffic can be initiated from behind this ASA from the 192.168.2.1 network, or traffic could also be initiated from the 10.10.0 /24 subnet. So let's see how to configure the exact same thing using the 8.3 plus syntax. With the 8.3, the NAT code has been completely rewritten, and it is a little bit of a learning curve to understand how to configure NAT using the 8.3 plus syntax. So in the 8.3 plus syntax, what we need to do is configure an object group for our source network. So those are the first two lines there, and name it object source network, for example, and put the subnet 192.168.2.0 with the /24 mask, and then configure another object group for our destination network. In this case, it's a 10.10.10.0/24 network. And now comes our manual NAT line, which is NAT inside outside. The source is static, which is my source net, and that source net will look like itself when it goes to the outside interface. So we got to repeat that one more time, and the destination will be static again, and my destination is the destination subnet. So everybody who looks at this line, the immediate question to ask is, why do we have to repeat that address or the object in the NAT line twice? So what is the object referring the source address on the inside, right? It is the source net. So how will this source network look like when the source is talking to the 10.10.10 network? It will look like itself. So now we've answered that question. So what we look like on the inside, what we're going to look like on the outside, and what is the destination going to look like when we initiate the traffic on the inside, and what's the destination going to look like once we egress the outside interface. So that's the reason why these object groups are repeated twice in that NAT 0 manual NAT line. And this one is dynamic PAT. Everybody knows dynamic PAT. We got to take everyone who lives behind the ASA and make them all look like an IP address that is routable on the internet. So that's dynamic PAT. So how do we configure that? In the old syntax, you would just do a NAT inside 1, which is the NAT ID number, and we need to configure a global with the exact same ID number. So in my NAT inside line, I have to include 192.168.2.0 with an appropriate subnet mask. and a global outside 1, it has to match the NAT ID, otherwise the translation will fail, and have the interface keyword, meaning everybody on the inside will look like the interface IP address when they go to the outside. The exact same thing, how do we configure in the 8.3+ syntax? Again, the source network has to be configured in an object. So object network obj 192.168.2.0, and I'm going to use the subnet address that will include everybody on the inside, and then the NAT inside outside dynamic and use the keyword interface. This is how dynamic PAT is configured in the 8.3+ syntax. The next one is a dynamic NAT. What is the difference between dynamic PAT and dynamic NAT? PAT is making everybody on the inside look like one IP address on the outside. The dynamic NAT is individually handing out one IP address for each person on the inside when they go out to the outside. So what we need to do, in the pre-8.3 syntax, we have to configure the NAT inside 1 with the NAT ID 1 and configure your whole subnet, whoever lives on the inside. In this case, it's 192.168.2.0 with a /24 mask. And now, everybody on the inside will take one IP address from the translated pool address. So this is dynamic NAT. So my outside global line contains 14.36.1.10.0, which is also a /24 network. How do we do that in the 8.3+ syntax? So I need to configure an object for my source network. I need to configure another object for how my sources are going to look like once they go to the outside. And then configure the NAT inside outside with the dynamic keyword and call my object group that I want to look like when my hosts leave the outside interface. The next slide is static one-to-one. This is very easy to configure in the pre-8.3 syntax. Let's say, for example, we have a web server and an email server. I want the web server to look like the .30 address that you see on the screen, and I want the email server to look like a .20 address. So you just simply configure static inside outside, and the global address comes first, and then the real address comes after that. How do we do that in the 8.3+ syntax? We know we need to configure an object for the source and then our NAT inside outside line. So we need two objects, one for the email server, one for the web server, and then statically map them. Notice here, the keyword here that I'm using is static instead of dynamic, as we saw in the previous slides. So statically map them to the 14.36.109.20 and the 109.30 address when they go out. So that covers static one-to-one. And what is static PAT? A lot of times customers get routable address space from the ISP, and they don't have very many addresses to spare. Sometimes they just get two usable addresses. They use one for the outside router, and they use another one for the ASA's outside interface. So whatever services that they have hosting behind this ASA, they all have to use that one address, one outside IP address of the firewall to look like when they go outside. And if it is a web server, then people from the internet need to be able to load the page that it hosts. Or the email servers on the outside world have to deliver email to their email server, all using the same IP address. In this case, we have to configure what is called a static PAT. The static PAT in the 8.3, the pre-8.3 syntax, you see that on the screen with the static inside outside. TCP, we specify the protocol and the port. If it is a unique IP address on the outside, we specify the IP address, and if we want to use the interface IP address, then we have to use the interface keyword. So let's see how to configure that on the 8.3+ syntax. Again, we need to configure an object group for our email server or web server, and then we do the NAT inside-outside. Notice I'm using the word static here because I would like to statically map this port so I can have inbound connections from the low security level to the high security level, and the service port in this case is 25. The reason for repeating 25 twice is I want to receive the packets destined to port 25 and again send it on the inside to the same destination, port 25, towards the email server. And that's the same case with the web server as well. Twice NAT. So this is source NAT as well as destination NAT. I don't have an example to show you how to configure this in the pre-8.3 syntax, but I'm sure everybody will know how to do that. It will be 2 static lines. Let's see how to configure the twice NAT using the 8.3 plus syntax. So let's say I'm a user sitting on the inside, and I want to load Google, but I don't want to load Google using Google's real address. When I ping Google, I get a name resolution with an IP address 72.14.204.105. If I want to load Google using my own subnet IP address scheme, how do I map Google's address to look like it belongs in my own network? So let's see how to do that. So first we need to configure an object for my source, and then I want to configure another object for my source as to how I'm going to look like on the outside. And then I'm going to configure another object for Google's real IP address on the internet. And I want to configure another object group for Google, how I want Google to look like on the inside interface. Once that is all done, it's very simple. We just need to configure a NAT inside outside, what my source is going to look like, what my mapped source is going to look like, what my mapped destination is going to look like, and what my real destination IP address is. This is called twice NAT. This is a bit confusing in the beginning, but once you get the hang of it, it's a piece of cake to configure. So here are some very useful links that would explain about the NAT order of operation in the pre-8.3 as well as the post-8.3 syntax. And these links are written by some of our escalation engineers, technical leaders, and other tech engineers. Some of the examples that I have written are listed in the before and after NAT config examples, the second link right there. Please keep these links handy. This will come helpful when you're configuring translation issues. Now let's talk about L2 adjacency issue. The problems that I present here have always been come to us in the form of cases that customers open with us. I've taken a few of them that were really challenging for us to figure out so everybody can learn from this. Here's one of the problems. As you can see, there are 3 routers on the inside of the ASA, right? And each of the router is routing traffic to certain subnets. And there's the ASA, there's a DMZ, and there's an outside. This is pretty much a typical topology that we see on all the cases that we work. So the problem here, what is the problem? So the guy sitting on the DMZ, the 14.36.112.125, he is unable to reach the 192.168.5.5. So obviously he's going from a lower security to a higher security. So we need proper static translation configured, right, for this DMZ host to be able to reach the inside host. Well, that relevant ASA config is there, as you can see there. The object for the 192.168.5.5 and statically mapped to 14.36.109.7 is there. And the route is there as well. All right. So what seems to be the problem? So that we collected DMZ captures. So we see the packets arriving from the DMZ PC, but they don't seem to leave the inside interface destined to our 192.168.5.5 host. So how do you configure captures on the ASA? The commands are right there. Cap, that's the command, and cap DMZ is the name of the capture. and I'm applying that on the DMZ interface, and what I need to match is all IP traffic from the host 109.7 going anywhere. This will capture bidirectional traffic. And I'm also applying the capture on the inside interface. As you can see on the inside, the IP address changes to the real address of the source that I'm trying to reach from the DMZ. So let's do the show cap. So we're trying to send a boatload of pings from the DMZ host, and we're going to see what captures show up where. As you can see, the DMZ captures are showing packets arriving, but then they don't seem to egress the ASA's inside interface destined to our host. So what could be the problem? So the next thing to check is, why is the ASA dropping these packets? So is it dropping it under the ASP drop, which is the accelerated security path check? So if you can see, we sent like 10,000 pings. As you can see on the previous slide, the buffer was full here. But then the 10,000 pings don't add up on the ASP drop counters. So this clearly says that the ASP drop has nothing to do with this, or the packets are not being dropped due to any of these security checks failed here. So what else? We've also done packet tracer output, and that shows it's permitted. So the next thing to see is, do we see anything in the syslogs? So we look at the syslog. We enable buffer logging for debug level, and as you can see, I'm grepping for this 109.7, which is the mapped IP address of the source that's on the inside. As you can see, the connection is built. It's built from one of the source on the DMZ destined to the translated address, and we see that. We also see the translation IP translated address show up correctly here, the real IP address, the 192.168.5.5. That shows up beautifully too. So we built and we towed it down too, and the packets are arriving on the DMZ, but they're not leaving the inside interface. So what could it be? We've checked route, we've checked translation, we've checked permission, everything is there, but these ICMP packets don't seem to leave the inside interface. They just are black holed. What would cause that? What does the ASA need to have in order to send that packet out the door, outside of the inside interface? What do we need to see? Our route is clearly saying that the 192.168.5.0 network lives behind that router 192.168.2.33. So what do we need to see? We should be able to see an ARP entry for that L3 hop that's on the inside interface. Do we see that? Do we show ARP and pipe include for the inside? There are very few hosts that we see. 2.2 is probably a PC, and 17 and 253 are two other routers that are routing traffic to other networks, but not to the 192.168.5.0 network. So our problem here is we don't have an L2 adjacency here. The ASA does not have an ARP entry for the 192.168.2.33 hop. So once we resolved that problem, the traffic went through fine. But it was pretty hard to troubleshoot this issue, but we had to go step by step. Watch the syslogs, check your route, translation, permission, check the captures, check the syslogs, and then come and check your L2 adjacency here. The next problem is a very interesting problem. This was a translation problem, and many devices were in the path. So the problem here is a very last line that I listed the problem. The PC, the guy sitting here on the bottom, 192.172.2012, he is trying to load a website. Let's say it is xyz.cisco.com. When he puts that name on the browser, it is going to resolve to 14.36.90.210. And the page simply doesn't load. So that's all the problem that was presented to us. So my goal is to get that to work, and in the process, I need to map the network and figure out what are the devices this packet from this client is going to take in order to be able to successfully load this page. So what happens when we put a name on the browser? As soon as we put a name on the browser is going to try to resolve the name to an IP address. So DNS resolution on UDP port 53 takes place. So now my question is, who is providing DNS resolution to this PCs, TCP stack. So the question comes, and it follows the gateway of this PC, which is the router that you see on the diagram. And right after the router, we see an FWSM. Right after the FWSM, we see the MSFC. Right after that, we see the web server's real address. So this is our own web server, which is hosted on 10.55.16.2 address. But when we get the name resolution, we get 14.36.90.210. So that is how this website appears for people on the internet to load this page. So that is configured on the ASA. So now the DNS resolution traverses all of these devices, goes out to the ISP's DNS servers, and the response comes back with the 14.36 address, and that does not load. So my source here is 172. So I'm investigating the next hop, the router. That's what I look at first. Right after examining the router, I see that the router is translating my client's IP address to 14.36.85.2. That's fine. I can get translated to anything because I need to go to the internet. This router is translating me to a routable address on the internet. And the next thing I need to check is the FWSM. So let's check what the FWSM is logging. So as you can see, the FWSM syslogs, I have copied and pasted those there for your reference. So it has my IP address, not my real address, my translated address after the router, which is 14.36.85.2, and that shows the source port number that my client has used in order to load this website. And it's also toned down. If you pay attention to the teardown syslog, it shows SYN timeout. What does SYN timeout mean? So I sent a SYN to load this website, but then I didn't hear anything back from that website or the web server. So the FWSM chooses to tear the connection down due to SYN timeout reason. And right after that, you see the deny TCP no connection. Look where it is coming from. It's coming from the 10.55.16.2 address. And that's right there in between the MSFC and the other ASA, which is which is our gateway to the internet. Notice that it is coming or the packet is destined to my client's translated address, the 14.36.85.2 address, and the source port all matches. You see the source port is 49439. That's the same source port for the build connection as well. So if I'm trying to load a page using the mapped address of the web server, the real address of the web server, the 10 address, is sending a packet, and that packet is a SYNAC packet. So the SYNAC packet is a response packet for the SYN packet. So why am I seeing a SYNAC coming from the 10 address when the SYN was sent to the 1436 address? Something strange there, right? So we decided to investigate further. So since the FWSM is receiving this information, then we got to go to the ASA and look and see what it has. So the ASA's configuration looked like that. I believe, somebody tried to resolve this problem. So the first static there you see is static inside-outside. That is for the people on the internet to be able to load this web server. So that's fine. Let's forget that one. That's a good static. The second one is static inside-inside. So inside-inside is a U-turn translation, and if you notice the IP address, that's for the mapped IP address of this web server. So that's a U-turn for our destination. And the next one is a static inside-inside also for the entire subnet that this router, which is the gateway to the PC is. So to U-turn all of those IP addresses and provide translation for the source. And of course, when you have U-turn translation enabled, the same security permit intra-interface is a required command. So all of that is configured. So now the problem is the destination NAT there. So my destination is 14.36.90.210, but then this ASA is U-turning my SYN packet, and the destination on the SYN packet ends up with the 10.55.16.2, and it reaches the server. So the server says, okay, I received a SYN, send to 10.55.16.2. Okay, I'm going to send a SYNAC back. So he sends a SYNAC back to our translated address, which is 1436.85.2, and that SYNAC packet comes to the firewall, which is what gets dropped with the 106015 syslog message that you see. So now how do we solve this problem? My God, this is a big mess. We can't load this website. So how do we solve this? The good thing about this case was the fact that the DNS request went through the ASA all the way out to the internet and got the resolution. So we could have very simply fixed the problem by doing this. Remove all of these lines from the ASA's configuration. Just leave out the very first line, or replace the very first line with the DNS keyword. Everybody knows what DNS keyword does here. It does what is called DNS doctoring when DNS inspection is enabled. If the response comes back to the translated address, it sees the DNS keyword and actually sends the 10.55.16.2 address back to the client PC. So when the client sends a SYN, it doesn't send it to 1436.90.210. It is actually destined to 10.55.16.2, and the web server will respond back properly. So that took care of this problem. But the question is, what if the DNS request doesn't go through the ASA? Then how can we solve this problem? Then the problem becomes somebody on the inside trying to load the web server using its public address and not the real address. That's a simple one. We always fix it by configuring what is called a destination NAT. In this case, if the DNS traffic wasn't going to traverse the ASA and we couldn't use the DNS keyword, so in that case, we could configure a destination NAT right on the FWSM to change our destination address from the 90.210 to 16.2. So long as the SYN goes to the right address, the SYNAC will come back from the correct 10.55 address. So we could accomplish it right at the FWSM. All right, now the most exciting problem we see that from time to time, which is no translations or connections are built through the firewall. The existing ones are fine, but we can't build anything new at all. They try to do all kinds of stuff. They try to fail over to the other unit. They try to reload. Once they start reloading, then absolutely no connections go through the box. But they will be able to establish SSH or ASDM or telnet connections to the box. There's a difference between to the box connections and through the box connections. To the boxes, you're just reaching the interface of the firewall, and through the boxes, you're traversing the firewall from one interface to the other. In this case, no new connections are built through the box. Doesn't matter TCP or UDP connections, no connections whatsoever. So this is a simple example here. As you can see, that's the MSFC. The inside VLAN is 801, and the outside VLAN is VLAN 26. So our problem here, no connections. We cannot ping the outside directly connected host from the SVI. Let's see. The source IP address in our case is 10.10.10.1, and the destination IP address is a directly connected host on the outside. So we can't even ping between these two. So what seems to be the problem? The basic check. We got to do the basic check. It's a directly connected host on the outside, so we got to make sure we have an ARP entry for that host. So check the route, check the translation, check the permission. All of them were there. But then show log shows no output at all. And the next thing to do is to configure captures to see if these packets, these ICMP packets even arrive on the interface. So how do we configure captures on the FWSM? unlike the ASA, where we can use the match keyword after like 7.2 code, we're not able to use the match keyword on the FWSM, so we have to configure access list. So my access list is bidirectional, so I have to add 2 lines, one for the source going to the destination and the other one for the destination back to the source. And I take that and configure that capture on 2 different interfaces. Gap in, apply that on the inside interface, and tie that to that access list that I configured up above. And configure another capture, call it cap out, apply it on the outside interface, and tie it again to that access list. So I do a show cap. We're sending pings from the SVI, but nothing seems to egress the firewall again. You can see the cap in showing packets, but the cap out shows 0 packets. So what could be the problem here? So the translation, as you can see, it is configured, perfectly configured, no problem with the translation. Let's also assume they've already tried to reboot the firewall, and there's still no connections. The next thing we have to look is, on the FWSM, we can do a clear NP all stats. The FWSM has 3 network processors, and we can see which of these counters increment when we send like 10,000 pings from the SVI with the timeout of 0. So this is the best way to troubleshoot. So we send a boatload of pings from one direction and watch which counter increments by the same number of count that we sent the pings from. All right, so when we do the show NP all stats and pipe exclude for non-zero counters, we see the deny con increment. So the FWSM receives the packet, but simply chooses not to process them. So why would the FWSM's deny con counter increment? To understand that, let's do show log. As you can see, the output that is grayed out in green shows TCP port 9999 as disabled. So the TCP logging is configured. Usually the standard for syslogging is UDP port 514. But in this case, TCP logging is configured. There is a rule with TCP syslogging. If the firewall cannot establish a 3-way handshake with the syslog server on the configured port, TCP port 9999, the rule is we simply will not build any connections at all. So I'll let everybody read through this slide. So UDP port is no problem at all. That is best effort, just simply port 514 traffic. But TCP, if we cannot establish a handshake, then we will not build any connections through the firewall. So what do we do to resolve this problem? We need to add a command, logging permit host down. So in case the syslog server is down, it may not be really down. It may reply back to ICMP, but still that doesn't count. We, the firewall, need to be able to establish a 3-way handshake to the syslog server that is listening on that TCP port 9999. Otherwise, we will not build any connection through the box unless we see this logging permit host down command configured. So we have filed a defect such that the firewall will log a message and notify the administrators in case this ends up being a problem. In our case, it was very hard to troubleshoot because there weren't any syslogs indicating that this is the problem. But this defect is not resolved yet, but once it is resolved, the administrators and the buffer logging will show something related to this, or it will let us know that the TCP syslog server being down is the problem. Dan?
Okay, let's go to our next polling question. Which firewall devices do you have installed on your network? Is it A, Cisco PIX 500 Series Security Appliance? Is it B, Cisco ASA 5500 Series Adaptive Security Appliance? C, Cisco Catalyst 6500 Series Firewall Service Module? D, iOS Firewall, E, a combination of the above, or F, other. Take a moment to answer on the right side. Okay, back to you, Corelli.
Thank you, Dan. All right, now we'll talk about one of the IPS global correlation issues. Three of my question managers today, Mike Robertson is from the Firewall team, Almedi Babzine is from the IDS team, and Aniket Rodriguez is from our VPN team. So any questions you have in any of these technologies will be very quickly and easily answered by our question managers today. The IPS problem, what is global correlation? So Cisco has many customers and thousands of IPS sensors deployed at many customers. These customers can choose to participate in what is called a global correlation. Say, for example, company A can receive packets from attackers, so they can participate and relay the source address of these attackers to Cisco. So Cisco can consolidate all of these IP addresses into their database. And some other companies, they may not choose to participate in this, meaning they may not send the information to Cisco so Cisco can consolidate those attacker IP addresses in the database. But all of these IPS sensors that are configured to receive these global correlation database update will receive what Cisco has in the database as attacker IP address or malicious IP address. So that figure there shows you how the IPS engine processes packets. A flow comes in. If we see that source address is part of that IP address in the global correlation database, then we just simply deny the packet and not process that or not send it through at all. So a lot of cases come in where this database update fails for whatever reason. So we can see what those reasons are and how to troubleshoot those. The majority of the reasons are shown in this slide here. Make sure there are no firewalls in the path between the sensor and the internet where it has to go to Cisco site and grab that database. Make sure DNS server is configured to allow global correlation features to function. Make sure the IPS has proper licensing configured. IPS has to run 7x code or higher in order to be able to make use of this. In IPS CLI, we could check show statistics, global correlation. We could also see messages in the show tag if we could look in the main log for some clues. And as far as advanced troubleshooting, we could log in with a service account as super user and curl, use that command with your CCO ID, and the output that you get will clearly indicate whether there is proxy in the path or what the reason is for these HTTP requests to get dropped and the database not get updated. Now, the next topic I want to discuss is about configuring the main interface on a firewall to also pass data. It's very simple. I know all of these slides have a wealth of information, but I made sure to provide as much information as possible so for people who are downloading the presentation for a later time, they would have all of these information and configuration samples at their possession to understand what was being presented today. So the relevant switch config here, you can see, and the management interface, the M00 interface on the firewall is configured as a trunk port on the switch. So the M00 port is connected to the gig 2/35 port on the switch, and you can see that port is configured as a trunk port. And the VLAN 36 has an SVI. And on the ASA side, the interface M00, as you can see, has been carved out into multiple sub-interfaces. The 0.10 is passing VLAN 10, and the 0.20 is passing VLAN 20. And the M00, the main interface, is also configured with the name and a security level and an IP address. So the problem here is we're not able to ping the SVI that we have configured on the switch from the ASA's M00 interface. So how do we troubleshoot that? Again, the basic steps, right? We do the captures on the management interface. We see packets leaving because we're trying to send the ICMP ping from the firewall towards the switch. So those ICMP request packets, as you can see, are leaving the firewall, but no replies coming back. And you can also see that the ASA is sending untagged packets. There is no VLAN tag on this packet. So when you read our documentation guide, it clearly says the main interface does not process tagged packets, right? If that is the case, then the line that is highlighted in green there about the native VLAN, that needs to be added on the switch site configuration. Without that, this flow that we're going to test for the main interface is simply not going to work. As soon as we configure that, now we can see that the replies are coming. The replies will come back to us. So for each request, we see a reply. And I just listed some sample as to how the packet capture looks like if we collected a packet capture on the VLAN 20 interface. As you can see highlighted down below on the green, we can see the VLAN tag on the packets, but that is not seen on the main interface packet captures. All right, Packet Tracer tool. How many of you have used this wonderful tool? We could use this tool for troubleshooting any flow that traverses the firewall. It's a beautiful tool. It walks you through the step-by-step what a packet takes in order to go from point A to point B. All right, so let's say the problem here is the host 192.168.2.2, when it is trying to talk to the remote network that lives behind, an IPsec tunnel, I guess, behind that router, 192.168.26.x. So the relevant config on the ASA looks like that. So we need 8.3 plus syntax here. So we need an object for the remote network, and that you see first, and then another object for the source. In this case, it's just not 192.168.2.0. It's everyone who lives on the inside. And the manual NAT line is configured beautifully. NAT inside, outside, source static, any, when going to the destination remote network. And for all other catch-all traffic that's into the internet, the inside host is going to look like the outside interface. And the route is clearly there for the remote network. The next hop is there. But then the packet tracer keeps showing us that it's going to pat everybody to look like the interface IP address, even when we talk to the remote network. Clearly, that's not the intention. The intention is the manual NAT line takes precedence over the auto NAT or object NAT to make it look like the interface IP address. But then, the flow is taking the incorrect translation here. So how to use Packet Tracer to solve this problem? So Packet Tracer input inside TCP, we're calling the source host, and I said, the source could be using any port higher than 1024 and destined to 26.65 on port 23. Standard telnet. I'm trying to telnet to the 26.65 host out on the remote network. So let's see what Packet Tracer shows me. So the route lookup, clearly the route is there and it's pointing to the outside, which is a good thing. The next thing is the NAT line it's taking is completely incorrect. It shows that it's going to take the dynamic interface NAT, right? So that's wrong. So why is it taking the dynamic PAT and not the manual NAT? So whenever we troubleshoot any problem, we got to focus on the IP address. Is that correct? Is the mask correct? Notice there, the object there for the remote network has the mask 255.255.255.192. And the packet tracer output that we used, or the destination host on the remote network, is 192.168.26.25. Does that guy even belong in this subnet? No. The route is showing clearly a /24 route, but then the remote network subnet had an incorrect mask. So that is the reason that it did not match the manual NAT line, and Packet Tracer kept showing us that it wanted to take the dynamic PAT configured. So once we fixed the remote network object to also contain the proper /24 mask, this flow beautifully shows, as you can see in the screen in the Packet Tracer, that it will take the manual NAT line that we configured. That's beautiful. All right, now comes a very common problem that everybody runs into. So how to map two different servers to the same IP address. So here's a little diagram. This happens in most of the customer setup. The internet email servers deliver emails to a Barracuda server or some mail laundry server that's hanging off of the DMZ. And once that email is all cleaned up, the email is sent from the DMZ server to the Exchange server on the inside. But the Exchange server sends out internet email directly without having to send it to the server on the DMZ and then for that server to send it to the internet. So what happens is, this is following the pre-8.3 syntax. The static PAT here is configured for the Barracuda server, so the email servers out on the internet can send email to it. But notice how the Exchange server is going to send email. It's going to look like the outside interface IP address, just like everybody else on the inside when it sends email to the internet. Now, as you can see, the static NAT PAT here that is configured for the Barracuda server, that is getting translated to the MX record, which is the mail exchange record for this customer's domain. But then when Exchange sends it out, it looks like the IP address of the ASA on the outside, and that is not the MX record for this customer's domain. So the email servers out on the internet, there's a very high possibility that they may drop these emails because it's not coming from, sourced from the MX record. So how do we fix this problem? Barracuda should receive emails sent from the internet email servers, and at the same time, Exchange server should also look like the MX record when it sends the email out. So how do we fix this? Very simple. So we need to configure a brand new NAT ID for the Exchange server. This is in the pre-8.3 syntax, NAT inside 2, and just put a host mask for the Exchange server and make it look like the MX record, the same address that the Barracuda static PAT is pointing to. That should take care of the problem. If it is the 8.3 plus NAT syntax, we could still configure that, and the example is about. So we configure an object group for the Exchange server, put the Exchange server's IP address in that object, and then configure a NAT inside outside, and dynamically translate the Exchange server to look like the MX record IP address. And one more object for the Barracuda, put the Barracuda's DMZ address and configure NAT DMZ outside. Notice this is DMZ outside because that's where the Barracuda server lives. And it is statically mapped to the MX record to service only the TCP port 25 and 25, which is email port. All right. Now I will do some online demo for you before I hand the mic over to Dan for the polling question 3. So this one, let us see if I can share my desktop here so I can show you a live demo. I hope everyone can see the screen now. This is the ASA, and the PC that you're looking at is right on the inside interface of this ASA. And what I'm going to demo now is to be able to load Google's page using the address that belongs on the inside. we talked about twice NAT, right? So we're going to take the source, 192.168.2.2, and make it look like the outside interface of the firewall, and we're going to load Google's page by this IP address, the 192.168.2.105, but then the actual real IP address of Google is actually that. So let's see how to configure that. So we need to configure an object, right? Object network. We can call it obj 192.168.2.2, and we can call it Google. So this object is configured specifically to load Google, right? Okay, so here I'm going to put just this host and then configure another object for Google's real IP address. So the host that is going to belong here is 74.125.229.194. And I'm going to configure another object to map Google's real address to something else that belongs in my own network, which is not being used, right? For example, 105. There's nobody with an IP address 105, which is what I want Google to look like. Okay, so once done, I want to configure my manual NAT line. So when you do a show route, you see my default gateway is pointing to the 172.16.1.1. Somebody else is providing, translation for me after I leave this ASA. So, and that interface is the corp NAT interface. So that's where the default route is pointing to. So my twice NAT line, or my NAT line, is going to look like. My source is going to dynamically look like that interface address on the all right. So that's my source, 192.168.2.2, and that's going to load Google. So how you configure that? So we configure statically map Google's real address to a mapped address on the inside. So what did we call that? I can copy and paste what I called it. All right. And then okay, looks like I made a mistake here in the object. Let's go and see what I called this group. That's Google's mapped address. And that one is the Google's real address. All right. Sorry about that. We got to do a destination static. So let's make sure our NAT line is correct. NAT inside outside. My source is dynamically going to get translated to the interface, and my destination is going to be statically mapped to what I want Google to look like on the inside, and this is Google's real IP address. So with this NAT translation configured, I should now be able to load Google's page with 192.168.2.105, right? Show run object ID. That's what it's going to look like. So we're going to try to load this page with that IP address. There's Google's page. So now if you look at the show con for 192.168.2.105, you will see that Google's real address that I took manually and I translated that to look like 2.105. So I can reach Google with 192.168.2.105 from being inside. So we can also see how to look at this via Packet Tracer as well. So I'll also demo how Packet Tracer is going to look like here. Packet Tracer input inside TCP 192.168.2.2 sourced from any high port going to that on. So it shows me that I'm capturing this particular traffic. My accessless applied is allowed. When I unnat, this is going to use this translation. That is a twice NAT that we configured. Google's mapped address and Google's real address. Everything is perfect. And when we NAT it, this is unnat coming from the outside to inside. And this is the NAT for the source. Sorry, this is the NAT for the destination. So my destination on the inside is 2.105, and once it leaves the firewall, the destination will be mapped to Google's real address. And this is the translation for my source. My source is going to look like my interface IP address, and this flow is allowed. So this is the result that everybody should focus on to make sure that this flow will be allowed through this firewall and follow every step of the translation that this flow is going to take. So that will conclude the sharing that we had to do today to show you a live demo. And I'll hand the mic back to Dan for polling question 3.
Okay, let's check out polling question number 3. Which security topics would you like to see in a future webcast? Is it A, more on firewalls, B, intrusion detection and prevention systems, C, VPN, D, physical security, E, AAA, F, Cisco Security Manager, or G, new features and products? Please let us know so we can plan our future webcasts. Okay, Corelli, back to you.
Thank you. All right, failover zero downtime code upgrade. We see a lot of cases where customers try to upgrade ASA code or FWSM code, and they're unable to look up for themselves whether or not they could do a failover zero downtime upgrade. Zero downtime upgrade is you just do not lose traffic flow at all. You don't have to reboot both the firewalls to suffer a downtime. Packets can be processed through one firewall while you reload the other firewall with a code upgrade. So let's see how the ASA and the FWSM support these. So if you want to look at, I'm going to upgrade my ASA from 707 to 825. So is this supported for zero downtime, or what is my upgrade procedure? So to find out the answers for that, you can simply Google what I said here within quotes and take the very first hit. The code that you're going to is 825. So everything will be documented in the release note link for ASA 8.2 code. So if you can read in that link, it clearly tells you what code from and to that you can upgrade. So if you see this, does zero downtime apply when upgrading ASA 5510 from 707 to 825? So when we check the previous question, the answer to that answered this as well. So it is not supported. So the code upgrade version of 82533, the first number is what we call the major release. The second number here is what we call the minor release, and the third number is the maintenance release, and the fourth number is the interim release. So in the upgrade guide that we referred in the prior slide, clearly said you can upgrade from any maintenance release to any other release, which is this green number highlighted here. If the third number, you can go from any number to any other number. The minor release, you can upgrade the minor release to the next minor release. You cannot skip one. So if it is 8.2, you have to go to 8.3. Only then the ASA upgrade is supported for zero downtime upgrade. And you can upgrade the last minor release of a previous version to the next major release. So I think that's pretty clear, so everybody can get the question answered about ASA zero downtime failover upgrade. As far as FWSM is concerned, whether we support the same thing, right? So in this case, we're going from 3210 to 4110. Is that supported for zero downtime? If you refer this link below, it clearly states you can upgrade from 321 to 41 or from 40 to 41 without installing any release in between. So clearly going from 3210 to 4110 without downtime is supported by Cisco. And now, what is my upgrade procedure? So the first thing you need to do is TFTP the code to both the units. Very simple command, copy TFTP /: image. And if it is multiple contexts, make sure to go to the active firewall and write mem all. This will save all the context config as well. If this is not multiple contexts, just simple single context, just issue a write mem on the active unit. Once done, the code is already there on both the units. Reload the standby unit. The standby unit will come up. It'll have the new code, and it will stay as standby because you already have an active unit sitting there. So then once a standby unit comes up with a new code, then we can make that as an active unit by issuing failover active. Once that is done, do a show failover on both the units. Make sure the new unit that just came up with a new code is active, and then you could go to the new standby unit and then reload that. So once that comes up, it's going to come back as standby because it will see an already sitting active unit with a new code, and the code will match, and everybody will be happy. All right, now before I close, I thought I'll bring to you two new features that came out. One is a scan-safe feature, and the other one is the ASA CX context-aware security. Let's talk about the scan-safe feature quickly. So this is supported in the new 9.0 code. What the ASA does is it receives the HTTP and HTTPS packets, and it proxies those packets to the scan-safe towers. There is no additional hardware required here, just software configuration, and the minimum code that we need is 901 code. It takes those requests, proxies it out to the tower, and according to the tower configuration, whether or not you're allowed to load the page will be decided, and the users will be able to load those websites. So users and groups, Active Directory users and groups can be used to authenticate these users and configure the tower policies based on that. How to configure? Very simple steps. The first section configures the scan-safe towers, the primary tower IP and this backup tower IP, and the license is a 32-bit key that is given to you when you purchase scan-safe. We configure access list, match for port 80 traffic, another access list match for your port 443 traffic, configure class map, match the access list that you just configured above, two different class maps, one for HTTP, one for HTTPS. And then we got to configure policy map, layer 7 policy for HTTP, layer 7 policy map for HTTPS, and then we configure a brand new policy map, or we could use an existing global_ policy and inspect for scan safe, and we should call this L7 policy map that we just configured. And then the final step is to apply the service policy, apply the policy map via the service policy line. And next is the context-aware security module. This is a new module that we support in the 5585 platform, the SSP10 and SSP20. We also support that on the 5512, 5515-X, 5525-X, 5545-X, and 5555-X. So if you need further information, you can click any of these useful links that I have provided to learn more about how to configure context-aware security. This is a lot more granular than the scan-safe towers. You can only block categories using the scan-safe feature. With the context-aware, you can go into the granular level. You can allow Facebook, but disallow the games in Facebook. so we can granularly watch macro applications used on the port 80. Other references here, useful ASA links, FWSM links, how to check a bug, whether or not it exists, or learn more about that in the bug toolkit link on the very bottom of this page. I hope everybody enjoyed today's presentation. Happy troubleshooting, and stay tuned for more in the future. Thank you. Dan?
Great. Thank you, Pirelli. Thank you. Excellent presentation. Now let's head over to our trivia question. What do Cisco Security Systems products and the location for the 2013 Super Bowl have in common? Have a look at these answers, take a guess, and then we'll cover this at the end of our presentation today. Is it A, in 2008, Cisco pushed firewall and VPN performance to new heights, with new ASAs announcing these new products the same year New Orleans last hosted the Super Bowl? B, Cisco expanded its security system product portfolio by adding to it threat defense and secure connectivity products and services for network businesses the same year that the Super Bowl was last played in New Orleans? Or is it C, Cisco delivered over 10 new products, software enhancements, and services across its security product portfolio in 2005, announced these new products the same year the Super Bowl was last played in New Orleans? Take a guess, and we'll cover our answer in a little bit. Now we're heading over to the Q&A portion of today's event. Remember, you can keep submitting your questions, so please do so. Let's start with the first one for Corelli. We want to migrate from the FWSM to ASA. What are issues that could arise when doing so, and what are the steps?
The FWSM to ASA SM module, we have a migration tool, so we can take the existing FWSM configuration, put it through the tool, and have it successfully convert that to an equivalent ASA configuration, and we can simply copy and paste those configuration lines onto the newly engaged ASA SM module. Shouldn't be a problem with that, but as any major upgrade goes, it will be wise to open a tag case and run your further questions by the tag engineer and get a hold of the migration tool online so you can feed in your old FWSM config and get the new modified config that you can copy on your ASA.
Okay, excellent. Let's move to our next question. Is it possible to look at both object network and the NAT statement associated with it in a single command?
Yes, once you upgrade the code, it used to be pretty hard in the beginning, but we have filed some defects and got that address now. Now when you do a show run NAT, the object shows as well as the NAT line associated with it within the object. Although I don't believe we still have resolved the issue where, say for example, we need to configure static PAT for the same server that listens on port 80, 443, and port 25. Presently, we have to configure 5 different objects for all the ports that the server listens on and configure a static PAT for each one of them. But we're trying to just configure one object and configure 5 different NAT lines under that object. I don't believe we've resolved that, but we do have resolved what you are putting forth as a question. And now we can do a show run NAT and see the object and the NAT line associated with it. Next question.
With dynamic PAT, we map many to one IPs. The inside network is mapped one IP on an outside interface. But is it possible to configure or map many to many like we config on the router?
Yes, that is possible. That is dynamic NAT, and we went over the sample. We have to, in the post 8.3 plus syntax, we have to configure an object for the inside network, and we also have to configure another object for what the mapped IP address is going to be on the outside, when we can definitely configure that. No problem with that at all. But it has to be one-to-one. So we could either do it dynamically or statically, but it has to be one-to-one. You cannot take a /16 network on the inside and try to only allocate a /24 network on the outside. That wouldn't be dynamic NAT, that would be dynamic PAT. Next question.
Okay. Yep. Next question is, does the packet tracer in the Cisco ASA ASDM show that this could be an ARP issue?
It does not indicate it is an ARP issue. So when all else fails, you don't see anything in the syslog, so the captures show packets ingressing but don't egress. The next thing to check is whether or not you have TCP syslogging configured and whether or not we have L2 adjacency to our next hop. Unfortunately, packet tracer does not show the MAC address or whether or not you have an ARP entry for your next hop. Next question.
Okay, next question. Do you know if for a dynamic PAT and a specific destination, I need to refer to a specific subnet mask for the destination through the network object group?
Would you repeat that question, Dan?
Sure, and I have it in your chat window as well. I know this one's a little bit confusing for me as well. Do you know for a dynamic PAT and a specific destination, I need to refer to a specific subnet mask for the destination through the network object group?
Yes, you would. If it is just one host on the destination, then you would configure, you wouldn't use an object group, you would just use an object, and you would configure a host under the object if it is one destination. If it is a whole subnet, then the content of the object would be a subnet instead of a host. I hope that clarifies that. Next question.
Okay. What are the steps to troubleshoot high CPU utilization on an ASA or FWSM?
Yes, that's a classic problem that we see. I covered that in my 2010 webcast. We can send you the YouTube link for that as to how to troubleshoot that. What we ask customers to send us is a show proc output taken within a minute or two apart during the time of the problem, not when the CPU has subsided, but during the time when it is spiking. We need the two outputs. So once you open a tag case and send those two outputs taken a minute or two apart, we can do a diff on that and figure out which process is taking the highest CPU cycle on the entire box, and we can alleviate that. It mostly be DNS or some kind of packet processing. If it is dispatch unit thread, then it is purely packet processing. If that is the case, we can see why are we seeing more packets that this firewall is processing today than a week ago when the CPU was normal. So it could be some sort of a packet loop on the inside. At that point, we could either do switch port spans or captures taken on the interface, either on the FWSM or on the ASA, to see what packets the firewall is even seeing or attempting to process. Most likely it will be a loop or some sort of inspection. Next question.
Okay. Do you have any recommendations for best practices for logging on ASA firewalls?
Again, we do not have any best practice. It all depends upon the traffic that your firewall is going to process and what you think is relevant information that you need to capture and save and archive from the firewall. Most of the customers look for builds and teardowns, which will clearly show what IP address is building a connection to what destination IP address through this firewall for safekeeping or report keeping sake. In that case, a level 6 informational log is good enough. But as a tech engineer, when we try to troubleshoot, we want to see every single log. So we always enable debug level logs, either the buffer logs, or we send it to the syslog server if it is too much information. Again, sometimes the logging server not being available will cause a lot of problem as well. So we send a syslog message to the syslog server, and if the syslog server is not there, then we see a port unreachable message come back as an ICMP message, and we try to catalog that packet, and we send that back to the syslog. So it just grows exponentially, causing a lot of problem. So whenever you configure syslogging, make sure you're configuring UDP or TCP. If it is TCP, make sure to add the logging permit host down command. Otherwise, if the TCP syslog server is going to be down or not listening on that port, then we will not build any connections through. So I leave it up to you as to how busy the firewall is and what level of logging will be convenient for your syslog server to get. I've seen firewalls log 500 syslog messages a minute to 40,000 syslogs a minute. So it just simply depends on the platform and the traffic that it processes. Next question.
Okay. If we want to check the services that are running on a server or one which is not directly connected to the interface of the firewall, is there any command like telnet 10.10.10.1.80 which are generally used on the switch or the router?
Telnet from the firewall is simply not allowed. It's a security device, so you cannot do that from the firewall. But you can use an adjacent switch or a router or a PC that's connected on the same subnet to do the telnet from the run line to a specific port and to make sure whether or not the server listens or not. Next question.
Okay. Why would you want to use twice NAT? Most external sites change IP addresses daily, including Google.
Right. I mean, I just cited Google as an example, but if this is a remote network, let's say separated between the two ASAs via an IPsec tunnel, let's say both networks are using the 10.10.10 address space. So you want to change what you look like when you reach the remote network, and you want the remote network, to look like somebody else when they try to reach you. So those are the reasons we use twice NAT, or also called as source NAT as well as destination NAT, all on the same line. Next question.
Okay. Could you better explain the command HTTP redirect inside HTTPS? Does this convert all pages to HTTPS generating from the inside interface?
This is the HTTP redirect.
Yeah.
Repeat that question.
HTTP redirects.
Let me answer that question offline. I'll take that for a later response. I'll make sure to answer that on the. I don't want to give any incorrect information here.
Okay. No problem. Okay, we'll go to the next question for now. Is code 9.x requires any hardware upgrade on the ASA 5510, for example, additional RAM?
Yes. So I'm hoping that when they want to run 9.0, they already went from 8.2 or prior to 8.3, which does require a memory upgrade. And the links that I provided on this slide, one of the links is all you need to know about ASA upgrade. So that link has a very nice table about the different platforms and what the new memory requirements are. Next question.
Okay. Are there any commands to check if an ACL is consuming more CPU than anything else?
Repeat that question again, then.
Sure. Is there a command to check if an ACL is consuming more CPU than anything else?
Yes, the CPU, the show proc output, if indeed the ACL processing is taking up a lot of CPU cycles, we should be able to say that when we do a diff on two show proc outputs taken a minute or two apart. Next question.
Okay. That actually wraps up our questions for today. And the question about the HTTP redirects, Corelli will be answering that question during the Ask the Expert event on the Cisco support community. So please do check back.
One of my question managers here chimed in for that. So it's just taking a port 80 packet and redirecting to port 443 on the firewall. So that's just simple redirection on the ASA. So I guess we got that answered as well.
Okay, excellent. Well, Corelli will still be answering other questions as well over the next 2 weeks on the support community site in case anyone has additional questions or is looking for more clarification. Just as a reminder today, when you close the window, you will see a survey evaluation. Please do fill that out. Everyone who does will be entered to win a raffle card for a $50 Amazon gift card. So please remember to fill out the survey. As I was mentioning, Corelli will be participating in an Ask the Expert event on the Cisco support community site from January 15th to January 25th. As a reminder, this video will also be available within the next 5 business days where you can watch the video and also read the Q&A. Some upcoming events from the Cisco support community. We have another one in Spanish on NXOS, routing considerations with virtual port channel topologies. That's on Tuesday, January 22nd. We have one coming up in Japanese covering fabric path refresher. That's going to be on Tuesday, January 29th. We also have an upcoming event in Portuguese that's covering Cisco Catalyst 6500 series switches, troubleshooting and best practices on February 5th. And we also have a number of events going on right now in English, covering a wide variety of issues, such as the Nexus 7000 NXOS, Cisco intrusion prevention systems. So please do check back at the Cisco community website for all these topics. And we have a few more: configuring and troubleshooting MPLS traffic engineering, Flex VPN, and Internet Key Exchange version 2. Cisco support community does participate in all sorts of different social media outlets. Please be sure to check us out on Facebook, Twitter, YouTube, Google+, and everything else that you can find, LinkedIn, and be sure to sign up for our newsletter. And just as a reminder, the Cisco support community does have many different languages available: Spanish, Portuguese, Japanese, Polish, Russian, and of course English. Okay, now we get to today's answer for our trivia question. Correct answer was B. Cisco expanded its security system product portfolio by adding to it threat defense and secure connectivity products and services for network businesses the same year that the Super Bowl was last played in New Orleans. Thank you again for everyone who participated today. Thank you to Corelli, our expert speaker, and we hope to see you very soon. Have a great day.
Thank you, everyone.